Okay, uh, my goal is to stay around 20 minutes max on this. I am going to be giving you guys an assignment to work on some level 2 unit conversions. So what I would like to do is actually go over some sample setups of level 2 type problems, kind of describe how are they different from level 1 problems, and then take you through setups of the three different types of structures within a level 2 type unit conversion. And then your assignment, I think there are a total of 12 questions on here. I'm going to have you guys start to work on the odds. Now, again, the key word there, in the end, there'll end up being two keyword concepts that you're going to want to remember about doing unit conversions. But the most important one is when you go to set up a unit conversion problem, you need to have the units that you need to cancel be diagonal from each other. Now, I'm going to be silly here again that diagonals can go this way or this way, as you're going to see today. If you review your level 1 problems, you will notice that the canceling always happened this way every time as we worked across. But because level 2 unit structure is a little bit, it has more pieces to it, it won't always be like this. Sometimes the diagonal will be like this. So let's start. Level 2, and I guess I could say we could start by looking at level 1, which sometimes what I will do to just look at a unit structure is use like letters A, B, and C. With level 1, this is what our basic unit was. It was just a single thing. It might have had a metric prefix in front of it, but it was just a single length, a single time, a single mass. One of the ways that level 2 problems, and I need to point out that this reference to level 2 difficulty, it's totally in our class only. Most people don't talk about it this way. But I call it level 2 difficulty because now, instead of just having one unit, we have 2 units. And those units could be divided by each other like this. So for example, a unit in the real world that would be like this would be like miles per hour, which is miles on the top and hours on the bottom. The 2 units could be multiplied by each other like this, which I'm not sure how many people are familiar with a unit that would be like that. If you work a lot on cars and you're familiar with the concept of torque and how tight you would tighten like a nut or a bolt, technically the units of torque are Newton meters, which means you'd have a unit called Newton times meters. And then the last type of unit, which doesn't necessarily look like this, it is a single thing, but it is being raised to a second power or a single thing being raised to the third power. Now we could go on and go to 4th, 5th, and 6th powers, but the truth is, for the units that we are going to expose you to here in this class this year, we will never get over a unit being cubed, so that's why I cap it at the unit cube. Now, for everyday units, if you have ever heard of, units of area, you have square inches, square feet. That's this type of unit. And if you've ever dealt with volumes in terms of cubic feet or cubic inches, that would be an example of this type of unit. So they are out there around us. Now, as far as a terminology goes, this level 1 type of unit is referred to as a fundamental unit because it is a single thing all by itself. These types of units and beyond, because technically I have difficulty levels all the way up to level 5. These types of units are called derived units. And that is because they are derived from taking multiple fundamental units and either dividing them or multiplying them. Okay, so that's a little background terminology. All right, so what we're going to look at is how do you set up a unit conversion problem that looks like these. So we'll try and squeeze in one of each type, and I'm going to do problems, a few of the even problems off of the conversion worksheet number 2, so that these are problems that you can see on that particular document. I am not going to go through the calculation side of things. I'm going to kind of leave that up to you. I may talk about it, but I'm going to leave that up to you to kind of play with your calculator, and then when we see each other in the next class period, if you said, I set them up, I'm pretty sure I set them up right, but I didn't get the right value on my answer, then we can talk a little bit more about calculator technique. Okay, so I'm just going to erase all this. I'm going to leave that diagonal thing up there. And we are going to go ahead and get started. And we will start, I'm going to start with number 4 because I want to begin with one of those units that has a A over a B. So for number 4, the problem is 6.91 E5, and then it has pounds / micrometers, and unfortunately I cannot make a dedicated like fraction bar. I can only use the slash for my fraction bar. So when you guys go to write these in your notebook to do them, I strongly encourage you to take that slash and make it a horizontal fraction bar. So we would have pounds on the top and we would have micrometers on the bottom. And what we are supposed to convert this to are kilo ounces over feet. So the reason for me so strongly suggesting this horizontal fraction bar is so that you can clearly see what's in the numerator and what's in the denominator. So when we go to set this thing up, we can see that diagonal nature better as we do our conversion. Now I'm going to have a little fun here. I am going to do the conversions for these two guys in different colors so you can kind of see when we get this setup put together, we are really doing 2 level 1 type conversions, but we're just doing them one after the other in the setup. Now, you do have to look at this and go, how am I going to get from pounds to kilo ounces? And this is where you might have to make use of the conversion factor worksheet for certain values that you need. But I think what most people would say is, well, I could go from pounds to ounces and then ounces to kilo ounces by adjusting with a metric prefix. And then from the micrometer, what most people would say is, I don't know micrometers to feet directly, but I can use my metric prefix capabilities to go from micrometers to meters, and then I can go from meters to feet with an appropriate English to metric conversion factor. So what we're going to do here is we will start with our 6.91 E5, and I will go ahead and start with both these things in black here, but now we can only convert 1 unit at a time. So if we're going to start by taking our pounds to kilo ounces, what we need to do is just not worry about this for the moment. So if we say, I need to go from pounds to kilo ounces, and so I'm going to do this in blue, I can introduce one of my magic H's, and my first step is going to go between pounds and ounces, so that means I need to have pounds and ounces in this magic H, but remember, we have to have units that we want to cancel be diagonal from each other. So I need to cancel the pounds, so that means the pounds would go down here, and I literally can put whatever unit I can convert pounds to up here, but in this case I want to go to ounces, so that's what I would place there. So my pounds are diagonal from each other, so they would cancel, And so right now I am at ounces. I need to get now from ounces to kilo ounces, so that means I need another magic H. And here I need to make the pounds go away and introduce kilo ounces, so that means I need ounces diagonal, so they cancel, and then I could take this to whatever I want, but I want it to be kilo ounces. So now the ounces have canceled. So at this moment, I'm good because now I have kilo ounces in the top, and that's what I want. Now at this point, now we can come back and say, oh, now I need to take care of the micrometer, and I need to get micrometer over to feet. So my first step is going to be micrometer to meter, so that means I need to introduce another magic H. Now I am ignoring this, kind of suspending it, because I've already finished it. Now I need to put micrometer and meter in my orange, my first orange magic H, but remember, I need things to be diagonal, and I want the micrometer to cancel, and the micrometer is down low, so that means I need the micrometer to cancel it up high. So that means the micrometer goes up there, and then I can convert that to meters here, and so this cancels that. Now we're not done because we want to get that meter to feet, so that means we need one more magic H here, and again we need the meter to go away and introduce feet, and since the meter is down low, we need the meter in this next one to go up high so that they would cancel, and we can convert this meter to whatever we want, but we want it to be feet, so that's what we'll do here. So this meter and that meter cancel. So hopefully you can see here in blue, because our unit was in the numerator, all of our canceling diagonal, I'm going to call it diagonality, was this way, but because our micrometer started in the denominator, once we needed to get it to cancel, our diagonal was this way. So it's not always that the thing you want to get rid of goes on the bottom. The thing you want to get rid of or cancel always has to go diagonal. But sometimes the diagonal will be like this, and other times it'll be like this. Okay, now that we have the units set up and we have our feet on the bottom here, we need to put in some numbers. Now, a couple of these numbers, you would either need to know them or you would go to the conversion factor worksheet so you could get the values. For example, ounces and pounds. I'm always surprised how many people don't know this. If you go to the grocery store enough, especially the deli section, you would become familiar with this. 16 ounces is equal to 1 pound. For the next one, this is our metric prefix conversion factor. And this is the one that we kind of make up as we need. And so I'm going to go through meticulously on these steps just to repeat my process for having you guys do this. So I have kilo, and if I ever ask you what number do we associate with kilo, the answer is +3 because the multiplier is 10 to the third power. Ounce does not have a metric prefix in front of it, so that means it is a base unit. And if I ever ask you what unit do we associate with a base unit, it is technically 10 to the 0 power. So once you have this established, the one that has the larger number is the bigger unit, and that gets a 1, and the other side, I write out an E, you might write out a 10 to the power, and then you look at these two values and think, how far apart are they? They are 3 spaces apart on a number line, so this will be a +3. So we're done there. If we come over here now and we transition to our micrometer to feet, we start with a metric conversion step here. We have micro and we have a base unit again. Now, micro, if I ask you, what number do we associate with it? This is 10 to the -6 for a multiplier, so what I'm looking for is -6. M, because it does not have a prefix, is a base unit, so we think 0 there. So when we look at these two and say, which of the 2 units is bigger, it's the one with the bigger number we associate with it, which would be the meter. So the bigger one gets the 1, and the other side gets the E, and -6 and 0 are 6 spaces apart, and because we put the 1 on the big unit, it will be a +6. Now the meter to feet thing here is a value that you could look up on your conversion factor chart, and there are 2 possible values. What I am going to do is I'm going to go ahead and use the one that has 1 with the meter, and that means this would be 3.28 feet here. If you chose the other one, you would have placed a 1 on the bottom and a .305 on top. And the only difference is which one you feel like putting there. But you don't need to memorize both of them. So at this point, we have this problem set up, and now you could start with this number on your calculator, and you could calculate through and get your answer. And the answer is on your worksheet, so you can see if you get that one right. Okay, so this is an example of that A over B kind of derived unit structure. So hopefully this will help you with a few of the problems on the worksheet. Okay, we'll do one more, and then we'll just kind of have you practice some today. So the other one that we're going to do is let's do number 2. And number 2 is 3.59 e -2 m times centiseconds, and we want to convert this over to inches times hours. Okay? Now again, I'm gonna use 2 different colors this time. I'm also going to use 2 different colors. I'll go with green and orange this time. So the 2 things that we need to do are take meters to inches, and then we need to take centiseconds to hours. So I'm going to start with the orange this time, and if we only focus on the meter to inch conversion, because remember, you can only change 1 unit at a time. I think what most people would end up saying is, you know what, I can take meters to feet, and then I can take feet to inches. And then if we ignore that for a moment and just focus on the time thing, we could say, well, I could take centiseconds to seconds, and on your conversion factor page, I threw out the value or the conversion factor for seconds to hours. So now that we kind of have our steps set up, we can go ahead and start, and we will, I got meters times centiseconds. We will start with the orange stuff here. So we got a magic H. Now, one thing to remember, this is the type of structure where you have an A times a B. Now, the thing to remember is that both of these are starting in the numerator, okay? So when it comes time to put our first magic H here, I put the little bar below this so that I can remember that these 2 units are clear, both of them are in the numerator. So when I want to go from meters to feet, I need meters to be diagonal. So this time the diagonal goes like this. And I want to go from meter to feet so that these meters cancel. And then I want to go from feet to inches, which would require another magic H. But I want the feet to go away, so that has to be diagonal. And then I want it to become inches there. And now I have the unit that I want in my answer. Now, again, when we did that, we ignored the centisecond to hour conversion. Now that we're done with the meter to inch conversion, now we need to ignore it, and we're going to focus on the centisecond to hour. So I'm going to transition to green here, and there's my first green magic H. If I want to get rid of centiseconds, remember it is in the numerator, which means it needs to go down here in order to be diagonal to cancel. And I'm going to convert that to seconds so that this would cancel that. And then I want to go from seconds to hours, which would require one more magic H. And again, to keep things diagonal, the seconds has to be in the denominator here, and we're going to convert it to hours so that these cancel, and I have my inches and I have my hours, and they're both in the numerator. At this point, we can go back and fill in values. Feet and meters is going to be a conversion factor that you can look up. Last time we did the 1 meter is 3.28 feet. I'm going to go the other way this time. I'm going to put 1 in front of the foot, and I'm going to use the 0.305 for this. Inches and feet, this would be one that I would hope that you would know, but if not, it's on the conversion factor sheet because you don't make it up as you go along. It's just kind of a relationship you need to know. 12 inches equals 1 foot. And now, when we move over to the next one, this one is one of our metric prefix conversion factors. Centi, we associate with the value of -2 because its multiplier is 10 to the -2. Seconds as a base unit is 0. So between these two, the seconds are bigger. So they get the 1 and the other side gets the E. And 0 and -2 are 2 units apart from each other. And so we have 1 over E2 here. And then in the last one, we have hours and seconds. And some people would go seconds to minutes, minutes to hours. But we'll be doing this enough that I would encourage you to remember the relationship between these two. 1 hour is 3,600 seconds. So now you have a setup taken care of. And all you need to do is go back and do your calculation and see if you get the right answer. Okay? So here's your sample for this kind of a conversion. And I'm just over my 20 minutes. So what I'm going to tell you is you guys can work on the odd problems from 1, 3, 5, and 7. So that would give you practice on 4 of them. And the exponent type derived unit we will talk about in class when we see you next time. But this will give you enough information that I think you can go ahead and attempt some of those problems. And if you're getting it right, awesome. And if you're not getting it right, be sure that you get in touch with me or talk to me during class next time so that we can kind of hammer out, is it a setup issue or maybe is it a calculation kind of thing that we need to get straightened out? So thanks for hanging in there, and we'll see you in class next time.